All right, guys, do not make me regret doing this for you. Today's notes, graphing inequalities in two variables. If at any time you need to copy something down, just stop the video and copy down what you need. Step number one says solve for y. If the inequality is not already solved for y, you need to solve it for y by isolating y, by moving everything except for y to one side of the inequality. Step number two, graph the boundary. It says C note, using the slope and the y-intercept. It's basically graphing just like as if it was in slope-intercept form and an equation in slope-intercept form with a couple of caveats. Step number three is to shade above the boundary if the sign is greater than or equal to, and you shade below the boundary if the sign is less than or equal to. Now about that note I said. You're going to use a solid line if it is a less than or equal to or a greater than or equal to. If it says or equal to, that means that this line is also part of the solution, and you would use a solid line with arrows on both ends. It says use a dotted line if it's just simply a less than or greater than sign. It does not have the equal to sign part. Okay? First example. Here's our inequality. It says 3x minus y is less than 2. So we need to isolate y. The first thing we need to do is to subtract 3x from both sides of the inequality. On this side, that cancels out. We're going to bring down the negative y is less than negative 3x plus 2. The next step then, since there's a negative ghost of 1 there, to isolate y, we're going to have to divide everything in here by negative 1. When I divide by a negative number, I know I need to switch my sign, so let's go ahead and do it. Negative y divided by negative 1 is simply positive y. And then negative 3x divided by negative 1 makes it a positive 3x. A positive 2 divided by a negative 1 makes it a negative 2. Okay? Now it's just a matter of graphing it. The first thing we need to do on our graph is to find the y-intercept, which happens to be negative 2. So we would put a point on the y-axis at negative 2. We have a slope of 3 over 1. It's a positive slope, which means we should go up 1, 2, 3, and then 1 to the right. We could do it again, 1, 2, 3, and 1 to the right. We could also go down 1, 2, 3, and 1 to the left. Since our sign does not have the or equal to part, we're going to use a dotted line because the actual line is not part of the solution. So we would start and we take our straight edge, hint, hint, and draw that boundary, okay? Then the last step said to shade it. If it was greater than or equal to, we would shade it above the boundary. If it was less than or equal to, we'd shade it below the boundary. Something that I always do is I find a point, I plug 0, 0 in, which I think is above the boundary. But if I plug 0, 0 into my inequality here, that would be 0 is greater than 3 times 0 minus 2. Well, 3 times 0 is 0, minus 2 is negative 2. Is 0 is greater than negative 2 a true statement? Yeah. Well, then that means that we need to shade the side of the line that has 0, 0 in it So we would shade this side of the inequality in. That means that any ordered pair in this shaded area, not including the dotted line, would be a solution to our inequality. Let's try another one. On this one it says x plus 5y is less than or equal to 10. We need to isolate y. We're going to do it by first subtracting x from both sides. That's going to give us 5y is less than or equal to negative x plus 10. And then our next move would be to isolate y by dividing by 5. So we divide every term in here by 5. That'll cancel out and leaves me with y is less than or equal to, that would be negative 1/5 x plus 2. Okay? Next, we go ahead and graph it. So we find our y-intercept, which this time is positive 2. We have a slope of negative 1/5, which means to go down 1 and over 5, 1, 2, 3, 4, 5 to the right. Or we could go up 1 and 5 to the left, 1, 2, 3, 4, 5. Since this one includes the or equal to, we're going to graph it with a solid line. So in this case, we're going to use a solid line. I'll make it blue to match my dots, okay? And it's going to go clear across our graph. Remember that a line needs to have arrows on each end. So we're going to go ahead and put our arrows on. It's a solid boundary this time because the points on the line are parts of the solution. It says that it is y is less than or equal to, so that means I'm going to shade it down below. Again, I can check 0, 0 to see if it's a true statement. So if I plug in 0 here, it says 0 is less than or equal to negative 1/5 times 0 plus 2. Well, that says 0 is less than or equal to positive 2. That's a true statement. So I would need to shade everything in below this line because everything is part of a solution. Every ordered pair below that line, including the line in this case, is a solution to this inequality. All right? One more, just because I love you.